Okay, let's dive right into this explainer. Today we're going to explore the literal microscopic recycling plant that is running nonstop inside your body. Did you know your kidneys filter about 150 quarts of blood every single day? I mean, every single second, your blood is circulating, picking up nutrients, but also accumulating all this cellular trash. We almost never think about it, but the mechanism keeping us from basically being poisoned by our own biological waste is an absolute marvel of engineering.
So it really brings up a vital question. How exactly does your body clean that dirty blood? Without a highly effective way to separate the trash from the treasure, our blood would quickly become dangerously toxic. Just think about everything you consume and everything your cells metabolize. All that waste has to go somewhere. The challenge your body faces here is just monumental. It needs a system robust enough to pull out the bad stuff, but precise enough to keep the good stuff flowing through your veins. Well, to answer that question, we really have to zoom in and look at the nephron. You see, your kidneys aren't just empty, hollow bags acting like coffee filters. They're actually packed with millions of these microscopic, structural, and functional units. These nephrons act as the ultimate biological filters, working relentlessly in the background. They are for sure the actual star of the show when it comes to blood purification. Here is our roadmap for today. First, the ultimate blood filter. Then, step 1, the big filter. Followed by step 2, selective reabsorption. And step 3, tubular secretion. And finally, we'll wrap up with the final exit route. The crucial takeaway here is that this entire complex operation is basically broken down into 3 highly efficient, distinct phases. First, you've got glomerular filtration, where the initial sorting happens. Second is selective reabsorption, where we literally take back what we need. And third is tubular secretion, which handles the final waste disposal. It's just a beautifully ordered system. All right, let's jump into part 1, the ultimate blood filter. Just to give you a sense of scale here, take a look at the top left. That shows the whole kidney, which you're probably pretty familiar with. But that entire winding, complex maze taking up the rest of the space, that is actually just one tiny, microscopic nephron. It's wild to think that the large kidney is basically just a housing unit for millions of these intricate looping structures, all functioning in parallel. Moving right along to number 2, step 1, the big filter. So right at the start of the pathway, blood literally rushes in through an incoming vessel called the efferent arteriole, and bam, it hits this dense, knotted cluster of capillaries called the glomerulus, which sits neatly inside the Bowman's capsule. Now, this structure acts directly like a giant biological sieve. Under high pressure, it forces the liquid part of the blood out of the vessel and right into the nephron's pathway. Think of this as the phase where almost everything gets dumped onto the conveyor belt. Waste, glucose, water, and salts are completely filtered out of the bloodstream and into the capsule. But, it's not a total free-for-all. The larger molecules, specifically the vital proteins, are safely left behind in the red blood vessel so they can continue their circulation. It's kind of like a blunt instrument at first, separating everything just by size. But wait, we definitely don't want to throw away the good stuff. That brings us to section 3, step 2, selective reabsorption. Let's see how this builds into an incredible rescue mission. Notice those winding yellow and pink pathways running right alongside the red blood vessels? Well, that close proximity is absolutely no accident. It allows the body to actively pull those beneficial molecules right out of the nephron's tubule and push them directly back into the bloodstream. This is where the system gets super intelligent. The body cleverly reabsorbs essential substances, basically taking back the good stuff. Vital resources like glucose, amino acids, and water are rescued and reabsorbed back into the blood. Meanwhile, it completely separates out the useless waste, intentionally leaving things like urea isolated in the tubule. It's a masterful sorting process, making sure we don't accidentally lose the fuel we need to function. Now we've got to deal with the really stubborn trash. Section 4, step 3, tubular secretion. During tubular secretion, the body takes one last pass to ensure the blood is perfectly balanced. The remaining waste products that we definitely do not want, specifically urea and excess salts, are forcefully passed down the line. If you follow the arrows on the right side of the pathway, you can see this remaining waste being pushed directly into the collecting duct for final disposal. The blood is clean and the waste is locked in. The intricate filtration is completely done, but the journey isn't truly over yet. Section 5, the final exit route. Take a look down at the macro exit plumbing at the bottom right. The newly formed urine is guided out of that microscopic nephron we just traveled through, moving from the collecting duct down into the body's main disposal network. It perfectly bridges the gap between this tiny microscopic cellular process and the macro bodily functions we are all so familiar with. Following this physical timeline, the journey is surprisingly fast. Waste flows from the collecting duct, travels down the ureter for a couple of minutes, sits stored in the bladder for hours, and finally exits the body in seconds via the urethra. When you step back and look at the entire cycle, it's a true masterclass in biological engineering. This 3-step nephron process, filtration, reabsorption, and secretion, seamlessly and continuously turns a rapid stream of potentially toxic blood into safely managed waste. And the craziest part, it does this without you ever having to consciously think about it. So, take a second to just marvel at this silent, non-stop process. It really makes you wonder, if evolution perfected a microscopic filtration system this flawless, what's going to happen when medical science finally learns how to successfully replicate it artificially?